Ever pondered how your computer juggles various tasks simultaneously? This happens because of a powerful component in your computer known as the operating system. An operating system, or OS for short, is a sophisticated piece of software that acts as the intermediary between you and your computer's hardware and software resources. Picture the operating system as the master puppeteer, pulling the strings, directing applications to run, managing files and directories, and ensuring your hardware is utilized effectively. It's responsible for everything from the clicks of your mouse to the loading of your favorite game. It's the gatekeeper, deciding which programs get resources, when they get them, and how much they get. In essence, the operating system is the unsung hero, quietly working behind the scenes to ensure your computer experience is smooth and seamless. It's like the conductor of an orchestra, coordinating multiple instruments to create a harmonious symphony. So, an operating system is essentially the brain of your computer, controlling all of its operations. Operating systems didn't just appear overnight. They have a rich history and have evolved significantly over time. The journey of operating systems began in the 1950s, with the simplest of systems. Back then, computers could only execute one job at a time, and there were no operating systems as we know them today. The first significant stride in the evolution of operating systems was the development of batch processing in the late 1950s and early 60s. This allowed computers to process multiple jobs together in a batch, significantly improving efficiency. However, these systems were still rudimentary, requiring manual intervention to load and unload each batch. The 1960s saw the advent of time-sharing systems, a revolutionary concept that allowed multiple users to interact with a computer simultaneously. This was a game changer, as it made computers more accessible and ushered in the era of interactive computing. In the 1970s and 80s, real-time systems came into the picture. These systems are designed to process data and deliver results in real time, making them ideal for applications that require immediate response, like air traffic control or nuclear power plant monitoring. The 1990s saw the advent of distributed systems, where tasks are divided among several computers, allowing for faster processing and better performance. This opened up new possibilities, including the development of the Internet and the World Wide Web. With the turn of the millennium, the focus shifted towards more user-friendly operating systems. These systems, like Windows, macOS, and Linux, have intuitive interfaces and offer a wide range of functionalities, making them accessible to a broader audience. In recent years, we've seen a rise in mobile and cloud-based operating systems, reflecting the shift towards mobile computing and the cloud. Operating systems have also become increasingly integrated, with many offering seamless connectivity across devices. Clearly, operating systems have come a long way since their inception, becoming more efficient and user-friendly with each iteration. But why do we even need an operating system? Can't we just run our programs without it? Well, let's dive into that. Imagine trying to manage all the hardware resources of your computer manually every time you run a program. You'd have to allocate memory, manage the CPU, control peripheral devices, and so on. Sounds complicated, right? That's where the operating system steps in. It takes care of all these complex tasks for you. It's like a super efficient manager that ensures everything runs smoothly. Let's say you want to print a document. Without an operating system, you'd need to know how to send instructions directly to the printer, manage the printer's buffer, handle errors, and so on. With an operating system, you just click print. The operating system manages the rest, communicating with the printer, handling the data transfer, and ensuring the job gets done. And that's just one example. The operating system manages all your hardware resources, ensuring they're used efficiently. It allocates memory, manages tasks, controls input and output devices, and much more. But it's not just about managing resources. The operating system provides a user-friendly interface, making it easier for you to interact with your computer. Whether it's the graphical user interface of a Windows PC or the command line interface of a Unix server, it's the operating system that makes it possible. As you can see, without an operating system, using a computer would be much more complicated. Now, let's delve into a key term associated with operating systems: throughput. Throughput is one of those terms that sounds more complex than it actually is. In the simplest terms, throughput refers to the number of tasks that an operating system can process in a given amount of time. Think of it like a busy highway. The more lanes you have, the more cars you can get through at once. That's throughput in action. Now, why is this important when talking about operating systems? Well, an operating system is like the traffic controller of your computer. It manages all the running applications, ensuring they get the resources they need to operate smoothly. The higher the throughput, the more tasks the operating system can handle simultaneously. This doesn't just mean your computer can handle more applications at once. It also means each application can run more efficiently. Because the operating system can process tasks quickly, each application gets the resources it needs faster. And when applications get what they need more quickly, they run more smoothly. So, when you're looking at the performance of an operating system, throughput is a key measure. It can tell you a lot about how well the operating system is managing its resources and how efficiently it's running your applications. So, in a nutshell, a higher throughput means your operating system is doing more work in less time. Operating systems aren't just about managing resources, they have a plethora of functions. Let's dive deeper into the labyrinth of operating system functionalities. First off, we have process management. This is the heart of any operating system, responsible for managing all the processes running on your device. From your background apps to the browser you're using right now, process management ensures everything runs smoothly. It juggles tasks, allocates CPU time, and even puts processes on hold when necessary. Next up is memory management. Ever wondered how your computer juggles multiple tasks at once? It's all thanks to memory management. This function of an operating system is responsible for keeping track of each byte in a system's memory and which processes are using it. It's like a librarian always knowing which books are in use and where they belong when returned. Then we have the file system management. This is your operating system's personal organizer. It's responsible for how data is stored and retrieved. Without it, finding a specific file would be like searching for a needle in a haystack. It's the function that ensures your saved documents are where you left them, and that your software runs when you click its icon. Last but not least, we have security and error handling. This is the operating system's built-in bodyguard and problem solver. It ensures that unauthorized users can't access your system and safeguards your data. When an error occurs, this function steps in, isolating the issue to prevent it from affecting the rest of the system. It's like a superhero, always ready to save the day when something goes wrong. So as you can see, an operating system is much more than just a resource manager. It's a multitasking maestro, a vigilant protector, and a meticulous organizer. It's the silent force that keeps your computer running smoothly, ensuring that you can carry on with your digital tasks without a hitch. From managing processes to ensuring security, the operating system does it all. We've covered a lot of ground today, haven't we? We started by unraveling the mystery of what operating systems really are. These unseen heroes that serve as the vital link between hardware and software. We then journeyed through time, witnessing the fascinating evolution of operating systems from their humble beginnings to the complex systems we now use every day. We explored the need for operating systems, understanding how they enable our computers to juggle multiple tasks at once and facilitate user interaction. Then, we dove into the concept of throughput, shedding light on how operating systems maximize efficiency and performance. Finally, we unpacked the functionality of operating systems, appreciating their role in managing memory, controlling peripherals, and ensuring security. So, as we wrap up, remember this. Every time you power on your computer, there's an operating system working tirelessly behind the scenes. Next time you power up your computer, remember the hardworking operating system that keeps everything running.